All right, in this video, I'm going to go over the slope-intercept form of an equation. By slope-intercept, we mean that the equation is in this form that allows us to see exactly what the slope of a line is and its y-intercept. What is the slope? Slope is how steep it is. How steep that line is, because a line just goes on forever in one direction and the opposite direction. It could be going down, it could be going up, it could be really steep, it could be, almost flat. But the slope will tell us how steep it is, and if it's going up as we go from left to right, or if it's going down as we go from left to right. The y-intercept, I hate to say it, but it's where the line intercepts the y-axis. Not sure how to put that in a better way. But we have this y-axis, right? We all know about that thing. It just goes straight down the middle of our Cartesian coordinate plane. And in the middle here, we start at 0, 0. That's our ordered pair, 0, 0. That's the origin point right there. And that is also where the y-axis intercepts the x-axis. So 0, 0 is kind of an intercept on its own. But we're talking about just one line that we're going to draw through the Cartesian coordinate plane. Could be any line, and it's going to hit that y-intercept at some point. Always. Unless you have a completely vertical line like the y-intercept. But that would have a slope of undefined. So that's technically not a line. So if a line goes on forever and it has a slope of has a defined slope and it's not divided by 0, it's going to pass through this vertical line at some point. That's what we call the y-intercept. There's also an x-intercept, but we're not going to do that today. All we need is the y-intercept. Okay? So now that you understand what those are, how do we know? How can we tell what those things are from this equation? Well, conveniently enough, that m part of the equation is being multiplied by x. That is our slope. So what is being multiplied by x in this equation? -3/4. So m equals -3/4. Wow, that was easy. What's the y-intercept? Y-intercept is this part, the b part. Now, I have this long line here because I'm also including the sign. The sign is very important, especially when it's negative. So that positive b there turns out to be -3 in our example. So we have a line with a slope -3/4 and a y-intercept of -3. What do we do now? Well, we graph it. How do we graph it? What does this tell us? Well, it tells us where to start. I start with the y-intercept. What is the y-intercept? Like, what is the ordered pair for the y-intercept? I mean, how do we know that this is the y-intercept? Well, like we've done before when you're graphing things, we just kind of input values for x and we get out y values, and we call those ordered pairs. We end up making them into ordered pairs, and then we graph those points and we kind of connect them together, right? Well, if this line intercepts the y-axis at -3, it will be at 1, 2, 3, right there, right? -3. What is the value of x at that point? Well, the y part tells us how far we went up and down, right? What does the x part tell us? Did we go left or right at all? No, we went 0. So the y-intercept ordered pair will always have a 0 for x because it's the y-intercept. X is always 0 all along this line on to infinity in both directions. X will always be 0 on that line, just as y is always 0 along the x-axis on forever and ever. Forever, ever. Okay, so we have 1 point. Now what do we do? Well, this is why I like the slope-intercept form, because now we just use the slope to find the next point. Now, we have a negative slope, so we have to keep in mind that it's not just rise over run all the time. It's actually like a negative rise over run. So so we actually need to go down 3 and over 4 because our rise is -3, not +3, and our run is 4. Okay? Does that make sense? If it's negative, we don't just always go up. Sometimes we got to go down over. But just so long as we remember that this is positive. So we're going negative, but this is positive. And we can also say that this is positive and this is negative when we're putting the slope in. And I know that's confusing because we always put that negative on the top of a fraction, but let me just graph it for you here. So we know it's going downwards, so because it's negative, we go down 1, 2, 3, right? And then we go over 4. 1, 2, 3, 4. Well, let me just line it up here. Boom. So this is the point 4, -6. 4, -6. Okay. How do I know that's 4, -6? Because I counted 1, 2, 3, 4, and I went down 1, 2, 3, 4, 5, 6. So if we put a 4 in here for x, 4 divided by 4 is 1. -3 minus 3 is -6. That actually fits. It's just like if we just plugged points in, plugged in values for x and got y's out, then it's, But since we have the slope, we don't have to do that. We can just count up and down and left and right and rise and run everywhere. So now that I've done this -3, down 3, over 4, now we're going to go up 3, left 4. 1, 2, 3. 1, 2, 3. That worked out nicely. It's right on the x-axis. Not the perfect line, but not bad either. And this line is -4, 0. I mean, that point is -4, 0. We put a -4 in for x, we're going to get 0 out for y. -4, 4's cancels, and the negatives cancel, so it's just 3 minus 3, which is 0. Yep. That was interesting. So that's our line, and slope-intercept form helped us find it pretty easily. All right, I'm going to do another thing here. Now, when you're given an equation to graph, it's not always going to start out in y equals mx plus b form. You got to be able to use the algebra skills that you've learned so far to transform an equation like this into the y equals mx plus b form. So you can find the slope and the y-intercept easily. So how do we do that? Well, remember solving for x? This time we're going to solve for y. We're going to isolate y. So we need to get that y by itself. How do we do that? Well, we need to get rid of this stuff and move it to the other side of this equation symbol, equal sign. So let's add the 2 first. That's easy. Add 2 to both sides. Got to do it. Both sides. Get 0 here. 3x stays the same. -12 plus 2 is -10, right? All right. Here's where it gets a little tricky for some people, and it's understandable. You divide by 5 to get rid of the 5, right? So that we can get y by itself. But we got to divide this whole thing by 5. Divide both sides of the equation by 5. Here's Joe, what? When we added 2, we only added 2 to that. Well, we did add 2 to 3x as well. It's just we combined like terms, you know? Those are the like terms. That's why, you know, adding 2 to both sides works like that. Division and multiplication works a little differently. It's kind of like a distributive property where we have 3x minus 10 being multiplied by 1/5. We got to distribute that 1/5 to 3x and -10. So we got like 3 divided by 5x minus 10 over 5, right? And yes, we can split them into 2 different fractions. That's nice. 3/5 x, that doesn't simplify. It's 10 divided by 5? Yeah, sure. 10 divided by 5, that's supposed to be a 5, not an s. 10 divided by 5 is what, 2? -2. There we go. What's our slope? 3/5. What's our y-intercept? -2. So we can actually draw that real quick. Do a really lame graph here. 1, 2. That's our y-intercept. 3 over 5. 1, 2, 3. 1, 2, 3, 4, 5. 1, 2, 3. There's the line. Y-intercept at -2 and a slope of 3/5. And it's positive and it's going up from left to right, so we know we did that right. My graph is very not to scale, but you get the idea. Thank you for watching.